Hello and welcome to Technical Utkranti. And today we are going to see the next question, which is trapping the rainwater. Don't get excited or confused. We'll see what the question is shortly. But before that, let's have a look at the thought for the day. Okay, so these are the questions that we have done till now. And now let's bring for you the question. Okay, so let's understand the question and the approach to solving the question. So you are given an array which represents the height of various buildings. We need to determine the trapped water uh, between these buildings. How are we going to do that? So just as a layman thought, if if we can determine the area of the water column at each building and then just sum it up, we'll get the answer. So how can we determine the water block area at a particular building? So if you see this particular building, how much water it can hold over here? It would depend that what is the biggest support on the left and the biggest support on the right, and the minimum of those two values would be the upper limit. And then once we know the upper limit, the lower limit is already given by the height, right? So if we subtract those two values, we'll get the height of the block. And width is already given to us as 1. And do it for all the buildings and sum it up. So let's look at the approach on the whiteboard. So here we have the array of the heights, and we'll create one array which would represent the height to the left, the maximum height to the left, and let's fill it. So there is nothing left to this element, so 0 over here. Then maximum to the left of this element would be maximum of this, comma, the nearest left element. So this will be 0. Then for this, maximum to the left would be maximum of this and this, which is 1. So similarly, we can just go on to fill. All right. And the maximum to right. So in the similar fashion, we would start from the right of this column and start filling in sequentially. So there is nothing to the right of this element, so we have 0 here. Then 0 comma 1 would be 1. All right. Let's write it correctly. 1. Then 1 comma 2 would be 2. 2 comma 1 would be 2. 2 comma 2 would be 2. 2 comma 3 would be 3. And then it will all be 3. All right. Now we need to find the minimum of these two values. Right. So minimum of these two values is 0. So when upper limit itself is 0, so yeah, we have the water column as 0. Here also it is 0. Here the upper limit is 1, lower limit is 0. So height is 1 and width is 1. So we have one area, 1 unit area of the block. Then 1 is the lower, 1 is the upper limit, and 2 is the lower limit. So no possibility of water filling over here. So 0, right? 3 comma 2, 2, and 2 minus 1 is 1. So we have 1 over here. Similarly, 2, 3 comma 2 is 2, and 2 minus 0 is 2. Then 3 comma 2 is 2, 2 minus 1 is 1, 2 comma 2 is 2, and the upper limit, lower limit is 3. So no possibility of water filling over here. Uh, 3 comma 2 is 2. Minimum of 3 comma 2 is 2, and 2 minus 2 is 0. So this is also 2 and 1, so no water filling. 1 and 2, no water filling. And this is 0, and this is 1, so no water filling. Okay, I made a mistake here. So 3 comma 2, maximum of 3 comma 2 is 2, and upper limit is 2, lower limit is 1. So we get 1 over here. And so we get the water filling as 6. So let's look at the code. And as we can see here that I'm calculating the max to left, max to right with these for loops. And then I'm just taking the minimum of the two minus the height at a particular this thing. So I'm taking care of the case when upper limit is less than the lower limit. So in that case, this would come out to be negative value. So that's why I'm taking the maximum of 0, comma, this calculation. So if this calculation is positive, we'll add to the answer. Otherwise, we'll add just 0 to the answer when upper limit is less than the lower limit. Right? So yeah, let's run it and see if we get the correct answer. Yes. So I hope you like the question. Please give it a like and subscribe to this channel. Thank you. Bye bye. Goodbye.